Amazement Square Anywhere. I'm Miss Tammy.
And I'm Miss Jennifer.
And today for Try It Tuesday, it's all about electricity.
So electricity is basically just the flow of electrons from one place to another. And we can harness the energy of those electrons flowing through to power things such as computers, TVs, and phones. Today specifically, we're going to explore static electricity, which is really just a charge on an object. So you've probably experienced static electricity before if you've been shocked by a doorknob, maybe your sibling, or your hair stood up after going down a slide. So static electricity is generated through friction. And here today we actually have our Graaff generator set up, which also generates static electricity. So let me tell you a little bit about how it works. When we power it on, inside this clear tube is a nylon belt, and that's going to spin around. At the bottom and top, there are two metal combs. Now these combs are close to the belt, but not quite touching. They're going to be close enough to help generate that friction that's going to pull those charges apart. So the positive charges of my atom are going to be pulled apart and get onto my dome here, and the negative charges are going to pull apart and go into the base. So now my dome is made out of metal. So it's a great conductor of electricity, meaning those charges flow easily through it. So we're going to see all those charges get on the top of my dome. Now one thing we know about electricity is that those charges don't like to stay there. They want to spread out and neutralize. So while we have all these charges here, they're looking for a place to jump to. So something that is the opposite charge, or at least neutral. So let's see what happens when we turn it on. So inside my belt is moving, and we can kind of almost hear some of that fuzz or charge that's generating on the top of my dome. Now here I have a 1, and this 1 is actually grounded into the machine, so that means any charge that comes to it will dissipate, or essentially spread out and go away. The top part is metal, so we're going to see if we can get some charges to bounce to it. So there we have a few sparks, and they almost look a little bit like electricity. So when this gets close enough, then my electric charge can jump to it. Now there's still a little bit of charge, so we're just going to make sure all the charge jumps to it and becomes grounded, so now it's safe for us to touch. Now Tammy, what do you think would happen if a person touched it while the machine was on?
I'm not sure.
Do you want to try it out?
Do you want to try it out?
I think you should try it.
Okay.
All right. So Tammy, you're just going to put your hand on this outside of the dome. Just make sure your hand just stays flat and stays on the dome the whole time.
Okay.
So we want to see if any charge flows through you, okay?
Okay.
So we're going to turn the machine on and see what happens. I don't hear as much of the charge as we did before. Tammy, do you feel anything?
No, not really.
I don't know. Let's turn it off.
Okay.
Do we think any charge went through you?
I just don't know.
Did you feel any shock?
I didn't feel any shock.
Well, let's see what happens. So this time, instead of using your hand, we're going to use the top of the dome, okay?
Okay.
So I'm going to put the top of the 1 next to the dome and turn it on. And it almost sounds very similar. So I still don't hear the same charge as we did before, but let's see what happens when I pull the wand away. There's that charge. So now, if I'm touching the dome, we don't see a charge, but as I pull it away, now that electricity has to jump to get to the wand. So this is an example of the path of least resistance. So electricity is actually just really lazy. So if there's something touching it, the electricity can flow right through it, it will. But now, as I pull the wand away, the electricity has to jump to get to it, and those are the shocks that we are accustomed to feeling when we touch a doorknob or maybe our friend. So let's try that again, but let's see if we can add something else to it. So go ahead and put your hand on the dome.
All right.
And we're gonna add some Science Krispies.
Okay.
It's just cereal.
I love Science Krispies.
Right, so we'll take our hand out. There we go. Now let's keep our hand nice and flat.
Okay.
So we're gonna use these Science Krispies to see if electricity is actually flowing through Tammy or not. So we'll do the same thing, just make sure you keep your hand flat on the dome, because we saw what will happen if you start to move it. So now, are you ready?
I'm ready.
All right, so we'll turn our machine on.
Oh.
Ooh, we can see some of them moving already, but let's see what happens when I put my neutrally charged hand close to it.
There they go.
Now we're getting more of them flying. So all of Tammy's body and the Science Krispies are becoming positively charged. what do we know about things when they are the same charge?
They want to repel each other.
Yes, they want to repel. So just like magnets. We'll go ahead and turn this off. Now you're safe to take your hand off.
Are you sure?
Yes.
Okay.
So they're going to repel from each other, which is the same reason your hair might stand up as well.
So you probably don't have a Van de Graaff at home, but you can still experiment with static electricity. Let me show you how. So things you need at home to do this experiment are a balloon, somebody's hair. You can use your own, but I'm gonna use yours. Is that okay?
Yeah, that works.
Okay, so I'm gonna take the balloon and build up a static charge, and then we're gonna see what happens when we put it near some items. The first item we're gonna use is just some table salt. So let's build up a charge. So I'm gonna get a nice static charge here on the balloon using Jennifer's hair. And now I'm gonna move it over to the salt and see what happens.
So it might be hard to see at home, but our salt actually moved around. You might have been able to hear it a bit from that static charge. That was pretty cool.
That was pretty cool. So let's try it using some bits of paper.
Okay.
Okay, I'm gonna build up a charge again on Miss Jennifer's hair. Okay, and I'm gonna move it near these bits of paper. Ooh.
So I see some of them start to jump. Some are actually stacking almost on top of each other.
Right, that's pretty cool. All right, so the last item we're gonna use to experiment with static electricity is this aluminum can. And I'm gonna build up a charge and we'll see if the can moves. All right, here we go.
Wow, that worked really well.
That did.
So these are just a few of the things that we use to test static electricity here in Amazement Square. What can you use at home? What objects work really well? What objects don't? Make sure to send us your pictures and videos of the things that you use to experiment with the static electricity. To see more videos like this one, be sure to subscribe to our YouTube channel. Thanks for joining us, and join us again next time on Amazement Square Anywhere.